Look at this next example. Notice you're given an equation, and I also graphed the equation for you here. This is a linear function. I can tell that it's a function because any vertical line I draw will only intersect the graph in at most one point. So this is a function. Now let's talk about what the domain and range are. So there's a nice way of telling what the domain is when you're given an equation. Actually, first you might want to put it into slope-intercept form where we're solving for y. But we're going to do that in a later video. But when you're given the graph, to find the domain, what you're looking for is the set of all x values that are taken on by the graph. So we saw that in this problem where here is the points that were leftmost on the graph. The smallest x coordinates were 4, and then you hit a coordinate here at 0, and then one here at pi, and then the next point on the graph happened at 6. Here, I don't have just discretely, finitely many points. I have continuously many, infinitely many points located on this line. So what I will do is look for the x coordinate that is furthest to the left. We'll notice that this arrow on the end means that this graph keeps going forever and ever, all the way down to -infinity. And same thing if I look for the highest x coordinate, this graph goes forever and ever, all the way, taking on x values all the way out to infinity. So because I can't list those, I'm not going to use this type of notation. I'll use what's called interval notation. In interval notation, you indicate the smallest x coordinate. In this case, I don't actually have one. It goes on to infinity, comma, and we list the largest x coordinate. In this case, I don't have one. It just goes to infinity. And then you either put them in parentheses or brackets, depending on if you're including the endpoints or not. And so this tells me that the domain is all numbers in between -infinity and infinity. Same thing here happens with the range. Only instead of looking at the x values, we're looking at the heights, the y values. What's the lowest height on the graph? And what's the highest height on the graph? Well, if I look at this arrow here, again, it's angling down, so it's going down forever. So there will be points on the graph that are at various heights all the way down to -infinity. Same thing if you look at the graph, this end shows that it's going up forever on the right. So that means that the heights are going to increase forever. So the range, the set of all y values, the set of all heights on this graph go from -infinity all the way up to +infinity. So I used interval notation to denote that. You could also say all real numbers. You could use that symbol to indicate that the domain here is everything.